A great deal of attention has been paid to mainframes in the recent months. The global pandemic has increased awareness of the need to accelerate mainframe modernization programs in the public and the private sectors. In fact, IT modernization is no longer a desire, but an operational necessity. So, ladies and gentlemen, welcome back to today's Mainframe Modernization Strategy session. In this session, we will discuss strategies, tools, and systems that can be utilized to modernize legacy or mainframe applications. Let's deep dive into today's agenda. So, we start today's session with an introduction to IBM mainframe. After that, we'll talk about modernization and why it is relevant in today's scenario. Then, we'll focus on the challenges involved in modernizing mainframe applications. After that, we'll talk about modernization strategies, tools, and system. And finally, I will share my experience with the mainframe migration and modernization projects. So do watch this video till the end and do let me know your feedback in the comment section. So before I start with today's session, I would request you all to do subscribe to our channel, and in case if you have already subscribed to our channel, then I would like to say a big thank you for your subscription. And if you like the content, then please hit the like button and do share this video with your friends. So let's get started with Introduction to IBM Mainframe. Businesses, government agencies, and educational institutes have relied on the mainframe for over 60 years. Even today, most of the world's largest banks, insurance companies, airlines, and retailers use mainframe. It is almost certain that your transaction was processed by a mainframe if you have done your shopping online, planned a vacation, or done your banking through a mobile app. The mainframe reliability, consistency, security, and the performance has cemented its role as a powerhouse of the digital economy. And the dependency on the platform shows no sign of slowdown. In fact, many companies view it as a platform for long term growth. Last but not the least, as new technologies emerge and the demand for better, faster services and applications intensify, the mainframe platform continues to evolve to meet changing market needs and power innovation. Now let's talk about modernization or digital transformation and why it is relevant. Modernization is the process of adapting something to modern needs or habits. The concept of modernization in the context of IT can mean different things to different people. For example, from customer perspective, an application modernization means the implementation of customer-centric digital tools like mobile application or a website that can improve the customer journey. On the other hand, from an architectural perspective, the application modernization could be to integrate various technologies, platform, and application across the enterprise in a seamless and transparent manner. Now, every individual has their own perspective on this topic. However, one thing they have in common is a focus on the use of innovation to deliver better business values for their organization. In reality, no one wants to change technology for the sake of being called modern. The value gained from modernization is what makes the journey worthwhile. Now, the question is why digital transformation or application modernization is required. The answer is pretty simple. If you look at the past 2 years, you will notice that businesses have been challenged in more ways than they could have ever imagined. In response to COVID-19 pandemic, a remote workforce is being deployed internationally, and technologies have been adapted quickly to support operations. With COVID-19, the digitization of customer interactions and internal operations have taken a quantum leap. Additionally, technology is changing rapidly, and it is a bit risky to continue to use traditional methods of managing your IT environments and business applications. The fear of disruption from startup or big tech companies such as Amazon or Apple is one of the biggest reasons why many businesses opt to modernize their legacy applications. But another important factor is the cost of operating mainframes, which is often expressed in terms of MIPS. The cost includes software licensing, hardware, maintenance, and operational expenses. According to a research from Advance, the average is 4,266 US dollar per MIPS annually. The focus on cost, however, can be too narrow because people do not discuss ROI, that is, return on investment. In reality, ROI can be quite attractive for mainframe, especially when your application is designed to deal with millions of transactions, in fact, billions of transactions in a day. Now let's talk about the challenges which is faced by businesses during the modernization journey. So as you know that mainframes are complex and old. They have been around for more than 50 years and their death has even been predicted as far as 1996. But predictions are not always correct. According to the last year report, 64% of organizations still use mainframe based application and these applications are between 10 to 20 years old. More than a quarter, that is 28%, are between 20 to 30 years old. In fact, the average mainframe application has a whopping 8.86 million lines of code written in multiple legacy languages across a single environment. So finally, considering the size and age of the system, modernization programs are complicated. The next one is right modernization expertise. So as you know that mainframe applications tend to pass through many hands over many decades, often without proper documentation of features or functional relationships. For many organizations, mainframes are like black boxes that include massive collection of code written by programmers who have retired or left the business long ago. So without the right modernization expertise, organization could find themselves in trouble. For example, TSB Bank in the UK that came to standstill after migrating 1.3 million customers to a new platform. It is therefore concerning that 36% of organizations consider the legacy modernization program they have completed to be a failure. Similarly, 77% have started but failed to complete at least one modernization program. And if you look at the region-wise statistics, you'll notice that 87% of them have started and failed to complete at least one modernization program, compared to 69% of companies in the rest of the Europe and 59% of the companies in the US. So it is extremely important that organizations consult experienced professionals with proven track record, conduct proper complexity analysis of the system, and develop airtight strategies before embarking on any modernization program. The next major challenge is skill shortage. The technology sector has long suffered from a skill shortage, especially the mainframe sector. Companies are unable to find the skilled staff which is required to maintain and extend these critical systems. As a result, over the last 12 months, we have seen the widespread panic and urgent calls for assistance from developers who understand legacy languages. For example, the state of New Jersey unemployment benefit system, when hundreds of thousands of residents quickly submitted applications to its unemployment system at the start of global pandemic. The sudden increase in the claims overwhelmed the mainframe system. Now let's take a look at the following statistics regarding the language and database used by mainframe applications. So clearly, 75% of the enterprise questioned says COBOL remains the most prominent language in their mainframe portfolio. Apart from that, they have assembler, another aging language that follows close behind at 66%. Similarly, the majority of organizations use non-relational database which date back as far as 1970s, with 76% reporting that they rely on database. Finally, organizations face huge disruption as developers with expertise in the most popular legacy languages and database retire. In most of the cases, new talent is not being trained to maintain and extend legacy application unless it is absolutely required. Now let's talk about modernization strategies and tools. To modernize or digitally transform your legacy application, there is no hard and fast rule. In general, there are four different strategies that can be used to modernize your legacy application. But before applying these strategies, you must carefully look at the various aspects of existing legacy application. When I say various aspects, it means cost, usage, underlying infrastructure, complexity levels, and the skill set required to perform digital transformation of the project. The following are the four different strategies. So the first one is encapsulating, second one is rehosting, third one is refactoring, and the fourth one is replacing. Now let's deep dive into each strategy one by one. So first one is encapsulating. Encapsulating involves accessing mainframe resources by using APIs such as REST APIs or SOAP APIs. A common use case is connecting a mobile app for customers or employee, or probably a cloud native application accessing data that is stored on IBM mainframe. As a whole, the encapsulate strategy has steadily gained popularity because it is more cost effective than other modernization methods. However, it has downsides as well. In fact, creating an API for a mainframe application is not an easy task because mainframe applications are a bit old and they are complex in nature. Apart from that, the functionality of these applications are not properly documented, and due to which you're not able to understand how exactly these components are interacting within the system or outside the system. In other words, there is a risk that API could break and no longer work. But it does not mean that APIs cannot be used on IBM mainframe. So before opting for encapsulate strategy, you should clearly understand the system components, its functionality, dependencies, and the underlying infrastructure. Now let's move on to our next section where we'll try to understand how you can expose mainframe application and data through API with the help of the following reference architecture diagram. So in the following example, we have a cloud native application which is actually hosted on a cloud platform. It could be Amazon, Microsoft Azure, or IBM Cloud. And this particular application is actually invoking an API to access customer information, which in turn invoke an existing mainframe application. It could be a Kix application, which is exposed as an API. Now let me explain each step one by one. So first of all, a cloud native application calls a manage API to get customer information. And with the help of an API gateway, the cloud native application invokes an API endpoint. It secures the API and invoke the corresponding API via IBM ZOS Connect. Now you might be thinking about the API gateway or the IBM ZOS Connect. So these are the important tools which is used to modernize your legacy application. An API gateway is an API management tool that resides between a client and a collection of backend services. It acts as a reverse proxy to accept all API calls, aggregate the various services required to fulfill them, and return the result with appropriate response. On the other hand, you have ZOS Connect, which is used to provide RESTful API access to ZOS applications and data hosted in subsystems such as Kix, IMS, IBM MQ, and DB2. The framework provides a concurrent access through a common interface to multiple ZOS applications or subsystems. It also provides the capability for Kix, IMS, and ZOS applications to access any RESTful endpoint inside or outside ZOS through RESTful APIs with JSON format messages. And there are different products which is available in the market, and you can use this product to digitally transform your legacy application. Now coming back to our example, and in third step, an API on IBM Z will transform the HTTP request into the input format of a Kix application, and this format is specified in a COBOL copybook, and after that it will invoke the Kix application. The Kix application would perform the required operation and it would return the result in an output format which is specified in a COBOL copybook. After receiving the response, the output is converted into JSON format. The response is then returned to the API gateway, which in turn return this JSON based response to the calling cloud native application. In this way, you can use encapsulating strategy together with ZOS Connect, API gateways, or any other tools which is available in the market to modernize or digitally transform legacy applications without causing any major disruption and surprisingly at lower cost. Now let's move on to our next strategy, that is rehosting or replatforming. So in general, Rehosting or replatforming is a process of transferring application and data from a mainframe to another platform. This could be to a public cloud such as Amazon Web Services, Microsoft Azure, IBM Cloud, or any other cloud which is available, or to a distributed environment. This approach is also called as lift and shift approach. The other platform will use rehosting software, and these softwares will be used to recompile the mainframe application. The biggest benefit of this approach is that you are not required to make any major changes in your underlying business logic. However, there are a couple of minor changes as per new platform. This will ultimately reduce the risk of malfunction or error in the software. So here are some additional benefits of using this approach. So first one is speed. Definitely a rehosting project would require less time depending on the size of the project. The next one is cost, and there's a significant saving in the infrastructure and operating cost. According to Micro Focus, the estimated savings are up to 90%. The next one is performance. There is a significant improvement in the performance of an application because it is deployed on a more modern platform. According to Micro Focus, the application performance gain up to 75% and the development productivity improve by 30%. In light of the benefit, rehosting has become one of the most popular approach for mainframe modernization. However, it is important to note that rehosting is really for a limited number of scenarios. It cannot be applied for every use case. So here are some of the important factors that you should consider when you're opting for re-platform strategy. So first one is standards. The mainframe environment should use standard tools and language like COBOL, KIX, JCL, IMS, and DB2. And in case if your legacy application is using non-IBM technologies such as Natural, Adabase, IDLE, Datacom, and Mentis, then the rehosting software may not be as effective. The next one is workload, and based on research from TCS, the peak workload below 5000 MIPS are more suited for rehosting strategy. In case if your MIPS is more than 5000, then rehosting strategy is not as effective. The next one is source code, and it is always good to have a source code which is well documented and well maintained. In case if there is any proprietary source code which is missing, then rehosting would be a challenge. Last but not the least, if rehosting is difficult, then partial mainframe exit is a viable option, where a well-defined portion of the mainframe landscape will be re-platformed, and the remaining elements can continue to reside on the original mainframes. This approach would definitely provide incremental savings related to mainframe MIPS. Now let's move on to our next section where we'll look at a couple of reference architecture diagram to understand how you can re-platform your legacy application. The first diagram showcases the typical architecture and tools which is used by a legacy application that is hosted on IBM mainframe. The next set of diagrams showcase the reference architecture for Microsoft Azure and AWS Cloud. And if you look at the diagram, you will notice that an Azure virtual machine or Amazon EC2 instance would be used to isolate and manage the resources for a specific application on a single instance, such as IBM ZOS that use logical partitions or LPAR for this purpose. A mainframe might use one LPAR for a KIX region with associated COBOL programs and a separate LPAR for IBM DB2 database. Apart from that, an EC2 instance or a virtual machine is deployed within a virtual network, and these machines run mainframe emulators and compilers that support lift and shift strategy. With this approach, the legacy application code is moved to the emulator with minor code changes. And from the user perspective, the migration is seamless as the application interface, design, and feel remains the same. And in most of the cases, the supported application source code is recompiled, and in case if your legacy application has some section or some piece of code that is not supported, then this particular piece of code is converted into a supported language and then it is recompiled. Last but not the least, you should carefully assess the code changes and the underlying infrastructure and tools which is used in your legacy application before opting for a rehosting strategy. Now let's talk about our next strategy, that is refactoring. So, in general, refactoring or re-architecting is about finding ways to improve and optimize the existing application on IBM mainframe. Legacy code like COBOL or PL1 is converted into Java or .NET or any other modern programming language. This often involves the use of sophisticated automated tools for conversion. The function or the business functionality of an application would remain unchanged. However, there are few changes which is required during the entire process. By using this approach, you can reduce the risk of major functional defects. However, the code base need to be tested extensively, and after some time when the program is stable in production, then you move to the next phase of your modernization. It is basically an incremental approach where you divide the entire legacy application into different phases and you work on each phase one by one. The only drawback of this strategy is that you need a lot of time and money to modernize your legacy application. One such example of refactoring strategy is a US Air Force project that involves a variety of vendors. The objective of this team is to modernize a large COBOL application which was designed 50 years ago. It was used to support the day-to-day supply chain and equipments for military missions. The US Air Force wants to transition this application to a Red Hat Enterprise Linux platform which would be hosted on AWS. The goal of this project was to lower the cost, increase agility, and improve security. Back in 1990, they have initially tried to modernize their legacy application, but eventually that was a failure. As a result, a different approach was taken, and this time they focused heavily on refactoring strategy. The project was ultimately a success, but eventually it took almost 3 years to complete the project. The entire project was divided into three different phases. The first phase, that lasts for almost 18 months, is the most complicated part of the project because it involved the usage of automated systems or tools for the COBOL to Java conversion. In phase 2, that lasts for almost 12 months, they have refined the code base which was generated in phase 1. A lot of manual effort is required in this phase to remove residual COBOL statements, overtones, and design elements to improve the maintainability of the code. In last phase, that is phase 3, that lasts for almost 3 months, the whole system was migrated to AWS. By doing this, the Air Force was able to use modern tools or systems such as DevOps or CI/CD. Each year, the US Air Force is expected to save 25 million US dollars. So this is how you can use refactoring strategy to modernize your legacy application. Now let's talk about our last strategy, that is replacing or rebuilding. So by definition, replacing or rebuilding existing legacy application is the most expensive strategy for mainframe modernization. In this strategy, a great deal of time is invested in understanding the existing legacy code, followed by redesigning of application component, and then the application logic is rewritten with the help of any modern programming language. It could be Python, .NET or Java. And as a result, mainframe footprints are eliminated completely. This approach is also termed as Big Bang rewrite. It requires a team of qualified professionals with a background in legacy language and modern programming language. The main challenge of this strategy is the cost and the time required to complete the project. In fact, sometimes the project gets delayed due to unknown issues that you encounter when you start working on the project. Another major issue with this strategy is that you have to maintain the existing legacy application during the course of the project. You're actually maintaining two different systems during the course of the project, and that would add additional cost to your overall estimates. And you should always keep in mind that some of the biggest failures in the mainframe modernization program have been with the rewrite strategy. So here are a couple of examples. So the first one is California Department of Motor Vehicle. The state government initiated a 208 million project to modernize their legacy platform. But ultimately, this project could not be completed and it was cancelled due to slow progress. The next one is Michigan Mainframe System. In 2005, the state has started a 10-year project for modernizing their legacy platform. The system was originally built in 1960 and it was used in 131 offices of Secretary of State. But within 8 years of starting the project, the lead vendor was fired. In fact, Michigan also filed a lawsuit against the firm. The project could not be completed and it was considered as a failure because vendor was not able to deliver even a single function. But this does not mean that any project which is following replacing or rebuilding strategy is bound to fail. There are projects which have been successfully completed. For example, Amadeus. It was launched in 1987 and it operates the largest transport reservation system in Europe. In 2018, the company retired its last mainframe computer. Its IT system has been transitioned to a platform that rely extensively on open system. So this is how you can use rebuilding or replacing strategy to migrate or to modernize your legacy application. But again, you should carefully assess various factors before opting for any strategy to modernize or migrate your legacy application to more modern computing platforms. Now it's time for me to share my experience related to mainframe modernization projects. Since the beginning of my career, I have worked on number of mainframe projects that include maintenance and enhancement project, compliance project, or mainframe modernization project. And I would precisely focus on mainframe modernization projects and what are the different challenges that we encounter during the course of the project and what is the outcome of that particular project. Apart from that, please note that I'm not going to share any client or company information in this video or precisely any piece of code which is required for explanation. So I would just going to let you know what are the challenges, what are the outcome and what are the strategy that we have followed and what was the end result of that particular modernization project. So the first project is an insurance domain project and in this case the client want to migrate from a mainframe to a non-mainframe platform. The initial attempt to modernize the legacy application was a failure. In second attempt, we have actually used a combination of strategies to modernize our legacy application. So first of all, we have used refactor strategy to convert all simple COBOL programs into equivalent .NET programs or classes. And for that, we have used automated tools. Apart from that, in our second step, we have actually used rebuilding strategy, where we have converted all the complex COBOL program into equivalent .NET programs or classes. Additionally, application data that was stored in DB2 database and vSIM files are converted and loaded into SQL Server database. And for data conversion, we have actually used automated tools. The new system is tested thoroughly before it is released to the production environment. In addition, both system, that is legacy, and the new system run in parallel for almost 2 years, and all calculations, reports and results have been compared on regular basis to avoid any inconsistency or the defects which was not identified during the testing phase. Now let's talk about the challenges that we encounter during the course of the project. So first and foremost challenge that we encounter was the system performance. Next is cost, which include licensing cost, development cost and operating cost. There's a significant increase in the overall cost compared to what was initially projected or calculated. Last but not the least, phase 2 of the project was launched to optimize the new code base and to improve the overall functionality of the product. So here's my experience with the second project. In this case, the client is seeking to modernize their core banking system. They want to replace their existing core banking solution with a more modern core banking solution that is hosted in cloud or maybe an on-premise infrastructure. But after 2 years of detailed analysis of existing legacy application and careful evaluation of various core banking solutions that is available in the market, they decided to go with a hybrid cloud computing model instead of a full-scale migration to a non-mainframe platform. Non-critical batch processing or applications such as data analysis, customer behavior scoring, customer credit scoring and approval, daily, monthly or annual reporting, etc. are offloaded from the mainframe. These applications are refactored and redeployed into a hybrid cloud. In addition, encapsulation strategy was used to share mainframe assets with cloud native applications. In order to improve customer experience, a new customer portal or mobile app were introduced. In fact, self-service features are more robust. Now customer can reset PIN, block cards or approve payments instantly. And they can also apply for new products online. Now let's talk about the challenges that we encounter during the course of the project. So first and foremost challenge is the complexity of existing legacy application, because this is an old system and it was never designed to interact with a mobile app or a web portal with the help of an APIs. So it was a challenging task for our teams to identify, isolate and then refactor those applications and move it to a cloud. At the same time, sharing of mainframe resources or assets such as programs or dataset with cloud native application through APIs. The next major challenge was the time and the set of tools required to complete the digital transformation. Last but not the least, the cost of modernizing legacy application is within our projections, and we are able to save a lot of money on MIPS as compared to last year MIPS. So far, we have discussed the different ways of modernizing mainframe applications, or probably legacy applications. Apart from that, we have also looked at a couple of real-world examples to understand how these strategies are used to complete the digital transformation of a project. As expected, and this is true, the media usually do not cover mainframe topics or trends. Moreover, these systems often handle applications that power infrastructure, so it is hard to get sense of what they can do. These machines are expensive and complex. They also require a team of talented IT professionals. Apart from that, mainframe is still a mystery for many people, and the common perception is that the industry is a backwater with little growth. But sometimes perception can be wrong, and this is certainly the case with the mainframe industry. This technology supports mission critical applications such as those that process ATM transactions or credit card transactions, or probably insurance claims. In fact, you might have seen various articles that emphasize that you should migrate your mainframe application to a non mainframe computing platform instead of upgrading the underlying mainframe hardware. So there are cases in which this option may be viable, but in majority of cases customer end up paying more. And this has been echoed in the survey. So one of the respondent who modernized their IBM Z platform stated that for every dollar we spend on IBM, it would have been at least $2 to go with a different solution. The cost difference is even greater for companies that regularly update their platforms. So this marks an end to our today's session, and I would request you all to smash the like button and share this video with your friends who are actually working on mainframe technology. Apart from that, I would request you all to do check out our courses on Skillshare, Udemy or Tutorial Point. We have already released our JCL course and we are about to release our COBOL course. And very soon we will publish our courses on Rex, DB2 and Kix. Last but not the least, please do subscribe to our channel for more such videos and don't forget to leave your feedback in the comment section. Thank you so much for watching this video. Bye bye and take care.